Hello everybody, we're going to talk about inequalities. Inequalities work a lot like equations, but there are a couple of exceptions. First, let's do an example of an inequality. So here's a word problem where we say, I have $20, I need to buy a paintbrush for $5, and tubes of paint cost $3.25. What are the possible numbers of tubes I can buy? So imagine yourself in this situation. You have $20 in your pocket, so you're gonna have to buy a paintbrush that costs $5, right? So, and then the paint costs $3.25 per tube, right? So this gonna be $3.25 times the number of tubes. Let's just use a variable. How about t? So $3.25 times t is gonna be the cost for the tubes of paint, and then the cost for the paintbrush is $5, right? So the most I can spend is $20. So whatever this value is, it has to be less than $20, right? So less than, or it could be equal to, right? If it was exactly $20. Let's say there's no tax or anything like that. So I have this equation, and I would solve it just like I solve an equation, just like this. I would subtract 5 from both sides, right? So $15, right? After I spend the $5, I have $15 left to spend on the tubes of paint. So then I have 325 times the number of tubes. So I could divide this 15 up into how many tubes can I get out of that, right? 325. So maybe here I get my calculator, and I estimate it's around 5. But let's get an exact answer. So it's important to estimate to make sure you're close. So I get 4.6, right? That's as many significant digits as we need. So the number of tubes has to be less than 4.6. So you can't buy half of a tube. So, well, unless they sell them in half tubes. But anyway, so you're gonna imagine that you're probably gonna buy either one tube, or you could buy no tubes, I guess. 0, 1, 2, 3, or 4 tubes of paint, right? So those are your possible answers. Now, this is a simple equation. We didn't have to do anything differently, but it does happen that when we deal with negative numbers, things get a little bit tricky. So how about if we had 10 is less than 20, a true statement just like that. Now, what if I were to subtract the same quantity from both sides? Well, let's just subtract 5 from both sides. So this would be 5 is less than 15. And this is still true, right? Now, what if I was to add a quantity to both sides? Right, plus 5, plus 5. So I get 15 is less than 25. Yeah, that's still true. Okay, what if I was to multiply both sides, right? 10 is less than 20. If I multiplied both sides by, I don't know, 2, so times 2 and times 2, I get 20 is less than 40. Yeah, it's still true. Okay, what about divide? So 10 is less than 20 if I divided both sides by 2. Okay, I get 5 is less than 10. Yeah, that's still true. Okay, it looks like so far everything's staying true. All of our properties are holding. But what happens with negative numbers when I multiply? So let's multiply this times, I don't know, -2. So I get -20 is less than -40. Actually, this is not true, right? Because when I look on the number line, I have 0 here, and I count down -1, -2, and down to -20, and then even further down is -40, right? And the positive numbers, 20 and 40, 20 is clearly less than 40, but here when we're saying it has more value. If you are in debt by $20, that is better than being in debt by $40. So really, this should have been flipped, right? So to keep it true, I need to flip that inequality symbol to keep this true, because this is false. So you will see that it is the case that anytime you multiply by a negative number, you have to flip this inequality symbol. And anytime you divide by a negative number, you have to do the same thing. And just to show you, let's go ahead and do that. 10 is less than 20, but if I divide both sides by negative 2, I would get negative 5 is less than negative 10, which is not true, right? Because you want to owe somebody $5 would be better than owing somebody $10. So you need to, this is false. So you need to flip that inequality symbol so that negative 5 is greater than negative 10 to make it a true statement. Okay, so how does that work out in equation solving? So let's take a look at this example. So negative 2x plus 4 is less than or equal to 5. So I would subtract 4 from both sides. So remember, subtracting doesn't mess things up. So it's okay to not flip the inequality symbol. So this is equal to 1, that's 0, and I get negative 2x is less than or equal to 1. Now if I divide both sides by negative 2, so this should trigger something in your mind. You say, oh, I'm dividing by negative, so I need to flip that inequality symbol. So you flip it around just like that, and I get x, so this is equal to 1, right? X is greater than or equal to negative 1/2. Now just to prove it to you, let's do what we always do, is plug it back into the original equation and show that it is true. So let's graph my equation and see. This is negative 1 right here, and negative 1/2 is in between. So this is greater than or equal to, so it means the value itself is included. So I'm going to color in the dot and say all the values that are bigger than it, so it should be this way. So all of these values should be solutions to this original equation. So one value you can check is 0. 0 should be true, right? Negative 1 should be false. So let me plug that value in and see if it works. So 0 times negative 2 is 0, plus 4, is it less than or equal to 5? Yes, it is. That's true. And I expected it to be true. Now what if I try negative 1? So negative 2 times negative 1 plus 4, is it less than or equal to 5? So this is 2 times negative 1, which is a positive 2, plus 4 is less than or equal to 5. So I get 6 is less than or equal to 5. No, that is false. And I expected it to be false, right? So if you forgot to flip it around, you would have got, x is less than or equal to negative 1/2. So you would have had this as your graph, and you say that, well, it's all of these values that are less than, right? But these values are not working, right? So it should have gone the other way. So this is one way you can check, is check 0. That's an easy one to check because multiplying by 0 is always 0. And check something that's pretty close on the other side and show that it's false. Okay, the value itself should be equal to, so I can check that one as well. So negative 2 times negative 1/2 plus 4, is it less than or equal to 5? So negative 2 times negative 1/2 is positive 1. So that's a 1 plus 4, which is 5, is less than or equal to 5, which is true. So that's the reason that it's filled in. If it was strictly less than, not actually equal to, then that would be an open circle, and that would be the difference there.